So we are Myungjee and Farina from Embodied Engineering, and a short note beforehand, we are quite an international team, and that's why we are going to have this talk in English. I hope that's okay for everybody. So yeah, as Tim mentioned, the industry is changing and so is technology, and that's why we are going to talk about natural interaction with embodied engineering. Yeah, you probably know the term engineering, but what does embodiment actually mean? We humans are spatial beings. That means we perceive our environment and our surroundings throughout our own body and the relation of the environment to our body. And that's why, yeah, you could say we are thinking with our body and with moving our body in space. So natural interaction is way more effective than two-dimensional graphical user interfaces as we had before. But let's move away from theory and back in time 100 years. So this is in the beginning of the 20th century. Henry Ford introduced his new car, the Model T. And he is quoted by saying that any customer can have a car painted any color that he wants as long as it is black. And you think, okay, why should a car only be available in black? Why can't I have my Model T in red or green or anything? Yeah, actually he was the first one who used fast mass production, and he was the first one who used moving conveyor belts and assembly belts. And so he had this simple and targeted approach to produce as many cars as possible in a short time. And that's why every Model T that left the factory was exactly the same. So there were no customization or personalization possible. And he chose the color black because it was the color with the shortest drying time at this time. So his approach is pretty straightforward, but at this time it was a huge success. Not only 10 years later, every second car in the world was actually a Model T. But today things are different. You have, of course, personalization and customization. Everybody would mad if you could only purchase a car in black. So you have thousands of different combinations possible. You have a shorter time to market today. The Model T was produced for almost 20 years. That wouldn't be possible anymore. And you have more complex technology and therefore also more complex assembly procedures. And humans and machines are working together in the factories on collaborating. So that's why production lines are, of course, also more complex. And the planning process is also more complicated. And communication is really important at this stage, because if you make any mistakes in the planning process, you lose a lot of money and produce a lot of overhead costs. So how could you plan a factory with this high level of complexity? People are creative, and that's why they use this. This is called cardboard prototyping. So you actually build your factory and your production places beforehand, made out of cardboard boxes, and test it with your own body. So here we are back in this concept of embodiment. You have the workspace in the real size and can test it, but it's quite effortful and expensive because you need a lot of material, you need a lot of space, you need all the people who you want to involve in this process at the same time in the same place. And it's only possible quite late in the planning process because it's quite rigid. You cannot play around with these cardboard boxes freely. You can rather test your plans that you have before. And that's exactly where we assess our embodied engineering suite with the software tools Boxplan and 4Stage. So this is a screenshot out of Boxplan. It's a virtual reality application for production planning. So you can actually try things out in virtual reality. And you can use this kind of prototyping at the very beginning of the planning process. and you can build your workplace with your own hand. So it's a virtual toolkit enabling people with different knowledge to actually prototype. You don't need this abstract knowledge of typing numbers in an Excel sheet and then thinking how it would look like. Yeah, so everybody can access it almost every time and almost everywhere. And people with different knowledge and different skills, also with technical skills, can suddenly work together, communicate, and the planning processes improve because people can understand each other better. And not only the planning procedures and the production lines have to be more flexible, but also the software, of course. And then we had the idea, okay, what can we do in virtual reality, what we can't do in reality? In reality, your locomotion and your movement is quietly bound to a two-dimensional surface, which is the floor. And in virtual reality, you could totally use the whole three-dimensional space. So you could go above and see your factory from above, and you could fly, you could try other things. And this idea was taken to a hackathon. That was the Hackvention that happened 2 years ago here in Hanover. And I wasn't part of the company at this time, but I took part in the hackathon as a student. And we figured out a locomotion method, so a movement method for three-dimensional spaces. And Myungjee will now tell us more about this specific part.
Okay. Yeah, so my name is Myungjee, and I'm a software engineer of Boxplan, and I've been developing the software called Boxplan since 2.5 years. So I will briefly explain about VR teleportation. Is there any of you who didn't use VR, and then how does the VR teleportation doesn't work? Is there any of you that who's not familiar of the teleportation? Okay, so I will briefly explain. So in real world, you can just like continuously moving around, or like just walking, or like jumping. But in VR, it's kind of difficult to do that because your space is sometimes limited. So I cannot just walk continuously, even though what I see is just like empty space, but there is actually the chair or wall in the real space. And if you're not actually moving, but you are moving in VR, so what you see is moving, then it causes like sickness, like you experience quite often in the car, because what you see is moving, but what your body is actually not moving, so this mismatch causes sickness. So that's why there's a teleportation in VR. So you point at some space, and then you click the button, and then you are suddenly standing here instead of continuously moving. So it prevents the sickness. It allows you to move more freely in VR space. But that's also kind of limited on the actual space, because why can't you move to that direction? Why can't you move to 1 meter above the ground? So this is one of our solutions for it. So if you really believe that we are in VR with special knowledge, that you can actually interact with the object, which makes much more things possible because it's less abstract, so everyone can understand. And how can you go up there and then build something, or even build a hook which is very high? So if I want to, I don't know, hang a tiny box on there, how can I reach there? So we developed some prototypes to solve this problem. So the first one that you can see, which look like Pokemon ball, is like that you click the button and then you move the ground level above. And the slider is also similar approach, that you move on, and then you're suddenly standing on above the ground. And then we tested other method like use the VR teleport, but you can also teleport to the above, because we have the box creation tool that you can point at something and then you can just like build a box very fast and immediately. And we took the same concept to our teleporter, and then we also tried the different type of platforms. Some are visible, some are invisible, and it also has different level of fences and so on. But there was still a problem. So we found out that the last method is the easiest to understand, and we decided on it after review and user testing. But there was still a problem. Since VR is very immersive and you cannot really believe that this is only a projection, only a picture that you're looking at, people also had the same problem when they are standing in a high place. They were afraid of high place, and they were super scared to stand on 3 meters above the floor. So we did some prototyping. We did user testing, and then based on this user testing, we found all the colleagues who had kind of fear in our company, and then we did the user testing and we did the prototyping. Actually, that was GIF file, but this is not moving. So the picture was basically that you move on to the above, and then there is some rail boxes which is appear from nowhere. So you are always standing on the platform. So wherever you're moving, you always have this kind of platform around you, so you cannot look directly down below the surface, and then you are always on the platform. And then we had this kind of problem that we actually need some kind of better indicator that you are actually moving on the ground, because some people accidentally cause it and then were super afraid of it. And then we changed some kind of indicators. We added indicators, which the foods shows that you can teleport on any surface, and the wings that shows that you can actually fly above the ground. Okay, so that was how we develop concept, how we allow the embodiment, how you can reach the actual object instead of binding everything into the high level of abstraction. So I will conclude our presentation. So why is the box plan, and why is the manufacturing process, why is the layout planning in VR more efficient and more intuitive, more easy to access to everyone? I mean, factory was never 2D. I mean, if you are drawing some object, it was like 2D projection of the 3D environment and space. But factory was never 2D. It was never flat. You actually build the tables and chairs, and you actually do works in the 3D space. But you only had the method on 2D. So you draw the plan of the factory, or you have the CAD file, which is projecting on the monitor, because that was the only method that we had at the time. But now, with virtual reality and with our product, Boxplan, and it allows us to directly think and build our factory and our environment in 3D space. So that was our presentation. So we have our booth somewhere there, so go left, and yeah. So we are Salt and Pepper, and then we are very glad to see you, and you can actually try out how it works and what kind of idea that we had. Thank you.